Hello everyone, welcome back to this session of PW International Boards. So here I am again to discuss with the next unit, that is chemical kinetics for your chemistry subject, with the paper code is 0620. Now when I'm talking about the chemical kinetics, basically if you look, then you will say that okay, we are going to study about this particular chapter only, that how about the rate of reaction, the factors affecting that, and besides that the interpretation of the data. But in this particular unit, we are having the several things, like we are going to talk about the equilibrium also, about the redox reaction also, and even a little part about the energetics also. Why I am saying energetics? Because in this we are going to talk about the activation energy, even about the exothermic and endothermic. If you want a detailed lecture of energetics, then you can just visit and see the chemical energetics lecture of mine. So let's see what all topics we are going to cover in this particular unit, that is chemical kinetics over here. And believe me, this particular one shot for the chemical kinetics is going to help you to ace your marks for the upcoming exams. So let's see the topics covered. So we are going to talk about the physical and chemical changes. Then we are going to talk about what are the chemical reactions, what are the different factors which are going to be there for the chemical reaction. Then we are going to talk about the rate of reaction, then factors affecting the rate of reactions, about the reversible reaction, chemical equilibria, the position of equilibria, and oxidation and reduction, that is our redox reaction. So let's begin our lecture. So over here, the first thing we are going to talk about is the changes around us. Now, if you just observe, there are the several changes which takes place around us. Like objects possess properties like state, position, shape, etc. But changes occur when these properties get altered. Like, say suppose if I am having a balloon. Now, if I put air, what happens? The balloon blows up, isn't it? And if I am going to put more and more air, ultimately what happens? It blasts. So this is what, that if I am altering a certain properties over there, what is happening? There is the effect coming on the balloon. Then changes affect the state, position, shape, etc., reflecting material transformations. Like in the case of the ice, if you just cool it down, what happens? It gets converted into a liquid. But at the same time, if you refrigerate a liquid, it gets converted into a ice. So what is happening? The state of the matter is changing from solid to liquid, or from liquid to solid. Similarly, in the case of the egg, if you put it on the flame, you get it fried. Similarly, if I talk about the chocolate, it gets melt on heating. So there are the several changes which takes place, and these changes takes place only when you are going to apply, or you are going to alter their certain properties. So moving ahead, we have the type of changes. In the case of the type of changes, we have basically the two types of the changes. The two type of changes are what? One is the physical change and another one is the chemical change. Now these physical and chemical changes, it is based on whether a new material is being formed or not. Physical changes. When we are talking about the physical changes, no new substance is formed, whereas in the case of the chemical changes, the new substance is formed. For example, in the case of the physical change, if you just melt the ice gets converted into a liquid, means there is no physical reaction is taking place, no chemical reaction is taking place, but only the physical state of the ice is changing, means H2O solid is converting into a H2O liquid. But in the case of the chemical reaction, a reaction takes place, they combine chemically, means there will be the breaking of the bonds, there will be the formation of the bonds. For example, the curdling of the milk. Now, when the milk gets curdled, what happens? It is because of the chemical reaction. So, basically, in the case of the physical changes, we have a physical change only, but there is no chemical reaction has taken place. But when we are talking about the chemical reactions, a chemical reaction has taken place over there, means there is a bond breaking or the bond formation over there. So let's see that what is the basic difference between them. If I want to talk, then the first point over here is the bond involvement. In the case of physical changes, no bond breakage or bond formation takes place. Whereas in the case of chemical changes, it involves bond breakage or the bond formation. Material change. Starting and ending materials remain the same in the case of the physical changes, whereas in the case of chemical changes, it results in the formation of new substances. Reversibility. Physical changes are reversible, but in the case of chemical changes, they are irreversible in the nature. Like once you have converted, for example, you have just cooked the rice, you cannot again make them uncooked, isn't it? Now properties. Properties like the color and boiling points remain in the case of physical changes, but in the case of chemical changes, it results in the different properties. So basically, in the case of physical changes, no significant observable changes in the properties come, but in the case of chemical changes, observable changes like temperature, color, etc. takes place. So here comes what is chemical reaction. So chemical reaction is a process where the molecular or ionic structure of a substance is rearranged, differing from a change in physical form or a nuclear reactions. Now, how you will say that chemical reaction has taken place or not? We can say that chemical reaction has taken place or chemical reaction can be accompanied by the following factors. Now, what are the factors? The first factor is going to be the evolution of gas. The second factor will be formation of a precipitate. Then third factor is going to be change in color. Change in temperature. Then you can have change in state and formation of new substance. So basically, if I say that chemical reaction has taken place, it is going to accompanied by these following factors over here. That is your evolution of the gas, formation of a precipitate, change in color or change in temperature, like we can say it is an exothermic or the endothermic reaction. Then change in state, like we have seen the example of the ice and water. Then formation of a new substance. So, coming to the rate of reaction. Now, before coming to the rate of reaction, let's talk about the kinetics only. That what is the need that we are studying about the chemical kinetics. Now, when I'm talking about the chemical kinetics basically it provides the proofs, or you can say it provides the evidence about the mechanism of a chemical process. That how fast or how slow the reaction is going to take place. So over here we are going to study about the mechanisms and evidences of a particular chemical reaction. Now when we are talking about a rate of reaction or you can even call it as a reaction rate, it refers to the velocity at which the reactants undergo conversion into products. Like we can have over here the ripening of the fruit. If you look, then ripening of the fruit or cheese making, these are the slow processes, but at the same time if you look the coal fire, it is a medium process, and at the same time if you look the explosion reactions, it is a fast reaction. So over here I am having a graph. This graph illustrates how the rate of reaction changes over time. So basically this graph is being plotted between the time and the amount of the product. Now this graph is being started from the 0. So over here the reaction is fastest at the start and large changes in the amount of the product in a small time has taken place. Now moving ahead, if you look, reaction is slowing down once it is having the steeper over here, becoming steeper over here. So smaller changes in amount of the product in a larger time is taking place. Now reaction is finished. Now when the reaction is finished, a small changes in amount of product in a large time taken place. So basically at the end what happens, that no more product is going to form. So basically a chemical reaction is fastest at the starting, and it slows down the reactants as the reactants are going to be used up. So there are 5 main factors that control the rate of chemical reaction. So what are the factors? First is the surface area of the reacting solids, concentration of the reacting solutions, pressure of gases, temperature, and catalyst or the enzymes. So let's talk about them one by one. The first comes the surface area of reacting solids. Now, when we are talking about the surface area of the reacting solids, the powdered limestone, over here we have taken example that the powdered limestone has a larger surface area, facilitating the greater contact with acid. And experiments with dilute HCl demonstrate the faster reaction rates with powdered limestone than with lumps. So, hydrochloric acid plus carbonate, calcium carbonate, if we look, we get the calcium chloride and CO2 gas and the H2O. So, the basic idea over here is what? That if you are going to take anything which is in a powdered form, so it is going to have a wider surface area. Now, when it is going to have the wider surface area, then the rate of reaction is going to be more. And if you are going to take something which is in the form of the lumps or in a concrete form, then you are going to have the lesser exposure of the surface area, because of which the rate of reaction is going to be lesser in that particular case. Okay. So this we are seeing with the help of an example over here, that is the reaction of the hydrochloric acid with the calcium carbonate. So if you are going to have the bigger size of your reactant, then the rate of reaction of course is going to be the slower. But if the reactant size is going to be the smaller, the rate of the reaction is going to be the faster. So surface area of the reacting solids, if you look, the rates of two reactions can be determined by measuring either the volume of carbon dioxide gas generated or the decrease the reaction mixture over time. So if you look, the powdered limestone left reacts faster with the acid than the limestone in the form of the in the lumps. So this shows how, if you are going to increase the rate of reaction, how you can increase the rate of reaction. The first, increasing the surface area can sometimes described as decreasing solid particle size. Like if you are having a cube of this big size, now you can just increase the rate of reaction by decreasing its particular size. Okay. So over here you can look that when we plotted a graph over here between the loss in mass and the time, how we got. For the powdered limestone, the graph curve is what it is here, and for the lumps of limestone the rate of reaction for the graph curve is lesser. So basically what happens that in this particular case, if you are having a powdered reactant, is like if I consider that I was having only the powdered reactant, it is going to has a steeper gradient at the start. Secondly, it becomes horizontal sooner, and thirdly forms the same amount of product. Same amount of product means that whatever the quantity you have taken of the reactant, that same amount you are going to get over here. So this is particularly a comparison between the reaction with the lumps of the reactant with the line of the graph with the powdered limestone. So this is how we are going to get the graph. So initial reaction rates between the hydrochloric acid and limestone are highest in the first minute, reflected by the steepness of the graph which we have seen, and powdered limestone reacts faster than the lump form, evidenced by the steeper slope of its curve. Next comes the concentration of the reacting solution. Now, when we are talking about the concentration of the reacting solution, gas producing reactions aid in studying the concentration effects on the reaction rates. The marble chips and the acid reaction can be adapted for this particular purpose. Like, we have taken the two setups over here, C and D, and altering the acid concentration. So, maintain the consistency, keep volume of acid, temperature, mass of the marble chips constant too. Now, look over here, we have taken a gas syringe, the thread, small test tubes, dilute HCl and the marble chips. So, if you are going to double the acid concentration, it is going to double the initial rate. Now, look how. Acid, when I am talking about, like over here we have taken the HCl acid. Now HCl acid is going to dissociate into H plus ion and Cl minus ion. Now if you are going to use a more concentration, it means you are going to have the more H plus ion. When you are going to have the more H plus ion, then of course the rate of reaction is going to increase over here. So over here, if I say about the concentration to the reactant with the reactant at a lower concentration, or the pressure also we can say, then the line of the graph for the same reaction at a higher concentration or the pressure is going to be how? The first thing is going to be has a steeper gradient at start. Then becomes horizontal sooner. Then forms the same amount of product. Okay, so if you look, I am having the lower concentration in the D and higher concentration over C. So how it is giving us the result? It becomes horizontal sooner, having a steeper gradient, and then forms the same amount of the product. So this shows that if we are going to increase the concentration, or even if I talk about the pressure, there will be the increase in the rate of reaction. So higher the concentration or the pressure leads to a steeper gradients. Equal product indicates increased concentration, pressure speeds reaction. The reaction rate follows reactant concentration, that is the law of mass action, and time is critical for altering the concentrations and affecting the reaction rate. So basically the rate of reaction and concentration, if we look mathematical expression, that we have the rate law expression, that is R is equal to K concentration of the A raised to the power X and concentration of B raised to the power Y. Now over here A and B are what? They are the concentration of the compounds or the molecules. X and Y are the reaction orders, R is the rate and K is the rate constant over here. If we look rate versus concentration graphs, it varies with the reaction order. So over here we do not get any question and we do not have much more detail. For the zero order, first order and second order, we get the such type of the graphs. If you look that for the zero order, it is a straight constant line. For the first order, it is increasing, and in the case of the second order, it is a curve. So gas reaction demonstrates a concentration effect on reaction rate. Increased pressure in gas reaction enhances the collision frequency. Now what is going to happen if in a cylinder, you just imagine you are having a gas particles. You know that gas particles, they are always in the motion. Now when you are going to increase the pressure on that, what is going to happen? The particles are going to come closer to each other and there will be the more, or you can say the much more frequency in that particular, in those particles. Why? Because they are going to collide with each other, they are going to collide with the container walls also. So which will increase the reaction rate. So pressure changes have no impact on reactions involving solids or liquids alone. So pressure of reacting gases, higher gas pressure is equal to steeper initial gradient, so faster plateau. Indicates increased gas pressure boost reaction rate. So again over here if you look, then when we are having a higher concentration or the higher pressure, we are having a steeper gradient. And in the case of the low concentration or the low pressure, we are having the not the steeper gradient. So this is how there is the effect of the pressure on the rate of reaction. Now basically, car engine combustion illustrates the pressure's role. Fuel hydrocarbons ignite with oxygen upon compression, driving piston movement. So this is how, if you just have a graphic for this explosion within the cylinder of a petrol engine, the piston compresses the gases because of which a car runs. Next comes the effect of temperature. Now when we are going to talk about the effect of temperature, the effect of temperature is what? That if you are going to higher the temperature. Now when you are going to higher the temperature, what is going to happen? The molecules, or the, you can say the particles, are going to attain the kinetic energy. Now when their kinetic energy is being increased, there will be the more faster rate. So of course the rate of reaction is going to increase. Why? Because on increasing the temperature, there will be the attainment of the kinetic energy, due to which there will be the more and more collision, and because of which the rate of reaction is going to increase. So again in the case of higher temperature, the steeper gradient fasters the plateau, shows temperature increases, so reaction rate also increases. So again the same thing is happening over here, that if you are going to have the higher temperature, then there will be the more collision. Now if you look over here, we have placed the flask with the sodium thiosulfate and hydrochloric acid added, and just observe the time for the cross disappearance indicates reaction completion via sulfur precipitation. So over here, if you look on recording the time, means for taking out the rate of reaction, we just record the time taken for completion of a reaction. So experiment repeated with solutions at various temperature and plotted a graph of cross disappearance time against temperature. So higher temperatures show quicker cross disappearance, signifying elevated reaction rates. Next comes the catalyst. Now basically if we are talking about the catalyst, catalyst is a substance which increases the rate of reaction without consuming itself. Now let's see that what exactly is happening with the catalyst. Catalyst basically is a substance that accelerates a chemical reaction without undergoing any permanent chemical alteration. Like over here, if you look, we are having the reactants. The two reactants over here, they just get attached on the catalytic surface. Now over here they form the intermediate, and this intermediate gets converted into a product finally, and we get a catalyst as it is, but it is never being consumed. Next is, like hydrogen peroxide decomposes slowly at room temperature. Manganese 4 oxide catalyzed accelerates the decomposition of hydrogen peroxide. The rate of oxygen production can be measured to observe the effectiveness of the catalyst. So basically, catalyst role is to increase the rate of the reaction without getting consumed itself. Now over here, if you look, manganese oxide can be recycled after filtration because it is not being consumed too. So catalyst efficiency in gaseous reaction depends on its surface cleanliness. Like we have seen over here in the case of the graph, in which the volume of the oxygen and the time versus graph is over here with the different amount of the catalyst. So basically catalysts are what? They are the substances which are going to speed up the rate of reaction without themselves being altered, and they are helping us in the rate of the increasing the rate of the reaction. So in the case of the catalyst, if you look at the higher temperature, you are going to have the higher, or you can say the higher or steeper gradient at the starting curve, and it becomes horizontal sooner, and you are going to get the same amount of the product. So catalyst enables chemical changes with a small amount. Catalyst remains chemically unchanged after reaction but can alter physically. For example, finer manganese 4 oxide remains post hydrogen peroxide decomposition. Now over here, this is a very important because we get a frequent question about the reaction conditions of the different reactions, and the reactions also, the most frequent question comes for the Haber's process, that is the manufacturing of the ammonia, and the second question comes for the contact process, that is the manufacturing of the sulfuric acid. Sometimes, or you can say the rarely, we get a question from the Oswald's method, that is the preparation of the HNO3, and in that they ask about the catalyst, they ask about the pressure, they ask about the temperature, means basically what are the conditions for these particular reactions. So Haber's process, that is manufacturing of the ammonia, in that particular case we use the iron as catalyst. Contact process, the manufacture of the sulfuric acid, we use a vanadium oxide. Oxidation of ammonia to give nitric acid, we give a platinum. And hydrogenation of unsaturated oils to form the fats, in the manufacture of margarines we require a nickel as the catalyst. Then we have two types of the reaction. The one reaction is reversible and the another reaction is of course irreversible. Now what are these reactions? Reversible reactions are the reactions in a chemical reaction that can go in both directions. If you haven't ever noticed that we have sometimes in the reaction the double-sided arrow, it means that that particular reaction can go in the forward direction also, and that particular same reaction can come in the backward direction also. Means converting the reactants into the products and products back into the reactants at the same time. Okay, so now over here, if I talk about the reversible reaction, in the case of the reversible reaction, what happens that when your reactants are combining and they are converting into a product, and as soon as the product is being made, it start converting into a reactant again. So for such type of the reaction, we say that they are the reversible reactions. So most chemical reactions are one way, converting reactants into products. So for example, the carbon and oxygen to form the carbon dioxide. Reversible reactions though allow products to revert to form the original reactants, and this creates a mixture that can contain both reactants and products with proportions adjustable by altering reaction conditions. Reversible reactions. An exothermic forward reaction implies an endothermic reverse reaction. Means if your forward reaction is going to be exothermic, then the backward reaction is going to be the endothermic, and heat transfer remains balanced in both the directions of the reversible reactions. Like we can have over here, say suppose nitrogen, hydrogen gives NH3 gas. So this double-sided arrow, it shows that the given reaction is what? It is reversible in the nature. Like over here we have the example, H2 plus I2 gives 2HI. This is a forward reaction. Reverse of it is going to be 2HI is going to give us H2 plus I2. So if I talk about the overall reaction, we got what? We got the H2 plus I2 gives 2HI, or 2HI can decompose into H2 and I2. Next we have the hydrated salts. Like in the previous chapter, we have already discussed about the hydrated and anhydrous, or you can say the salts also. Let's see more about them. Hydrated salts. Basically, we have the few salts in which there is the presence of the water of crystallization. And because of that presence of the water of crystallization, there is the change in the color. Like the hydrated salts contain the water of crystallization which affects their molecular shape and the color. So, water of crystallization is stoichiometrically included in the structure of some salts during crystallization. For example, in the case of the washing soda, we have 10 molecules of the water. In the case of gypsum, we have the 2 molecules of water. In the case of copper sulfate, we have the 5 molecules of water. Then we have few other examples also, like FeSO4, 7H2O. We have cobalt chloride, 6H2O. So over here, basically, if I talk about the most frequent question we get from the copper sulfate, and then at second number about the copper chloride. So here comes the chemical equilibria. It is for the extended student. The reversible reactions occur in closed system. Now look, understand it more. When I am talking about the reversible reaction, so let's take one container. Now in this container, say suppose I am having a, let's first of all make a water. Okay, now this container is an open container. So what is going to happen if we are going to heat it, then on heating the water is going to evaporate. But what we do, we just place a cap on it. Okay, we just put a lid on it. Now what is going to happen? Now when you are going to heat it, this water is going to convert into vapors. And it is going to come and touch the surface of the lid, where it is again going to condense and again changing to a water state. So basically what is happening, the water is converting into a vapors, vapor is converting into a water on heating. So how this particular process is possible? When I just kept a lid over there, means this type of the process or the reversible reactions are done in the closed systems only, where reactants and products are contained without escape. So in closed system, while heating of calcium carbonate, carbon dioxide gas produced cannot escape, leading to the establishment of the equilibrium within the container. So equilibrium state is what? When the concentration of the reactant is equal to the concentration of the product. So over here what happens when we are saying the reaction has achieved the equilibrium, the concentration of reactant is equal to the concentration of product. Even you can also say this thing, that rate of forward reaction is equal to the rate of backward reaction. So over here you can just look, we have taken the example of the calcium carbonate. In the case of the calcium carbonate, in the first one, we have covered a lid over here. There is the presence of the lid on this particular container. So because of which what is happening, this carbon dioxide is not able to escape. But over here, this carbon dioxide is able to escape because there is no lid, means it is a open container. So if you look, we got the arrow which is one-sided only, but in this particular case, it is the double-sided arrow. So at equilibrium, reactants form products and products reform reactants at the same rate known as the dynamic equilibrium. The rates of the forward and reverse reactions are equal to equilibrium. Like over here, you can just see like this, that if I look, in starting we have only and only reactant, isn't it? And what happens simultaneously, the product starts beginning. Now the point comes where their concentration becomes equal. So this particular point we call that equilibrium is being achieved when the concentration of reactant and product becomes equal, or you can say the rate of forward reaction is equal to the rate of backward reaction. So like over here it has shown equilibrium can be approached from either direction in the reactions where all components are in the same phase. Like over here, if you look, we are having a reverse reaction and the forward reaction. So what happened? They just met in a point where their rate is become equal, and that particular condition is called as a equilibrium. So heating a sealed mixture of hydrogen iodide forms hydrogen iodide. At a specific temperature, the concentration of hydrogen iodide is stabilized regardless of the initial mixture. So chemical equilibria shows equal rates of HI formation and decomposition, that is chemical equilibrium is going to be H2 plus I2 gives 2 HI. So if you look slowly the H2 and I2 they are decomposing, or you can say they are reacting to form a new bond, whereas the product HI we are getting with the increase in its concentration. So next is the position of equilibrium. So the balance of the reactants and products in a reversible reaction under specific temperature and pressure conditions, if we look, the equilibrium position shows whether a reaction favors reactants or products. If products are dominated, equilibrium is to the right. If reactants are dominant, it's to the left. So basically equilibrium position gets shift according to the favor of a reaction towards a reactant or the product's dominancy. Now, endothermic reaction. We all know endothermic reaction means that heat is being absorbed. So, if you are going to increase the temperature, the equilibrium is going to shift in the direction that absorbs heat to warm the reactant to counteract the increase in temperature. Now, look over here. In starting, we are having the energy of the reactants which is low. And as the reaction occurred or taken place, or you can say the proceeded, we get the products. So over here the energy of the product is higher. And why it is so? Because in the case of the endothermic reaction, we require to give the heat to the reactant. Now coming to the exothermic means heat is being released. So if you are going to increase the temperature, the equilibrium will shift in the direction that releases the heat towards the products to counteract the increase in temperature. Now in this particular case, the energy of the reactant is going to be high, whereas the energy of the product is going to be low. Next is the effect of pressure changes. So increasing the pressure favors the side of the reaction with fewer moles of the gas to reduce the pressure. Of course, when you are going to increase the pressure, what is going to happen? The particles are going to come together. And when they are going to come together, there will be what? There will be the fewer moles over there to reduce the pressure. So decreasing the pressure favors the side with more moles of gas to increase the pressure. So if you look over here, we have shown the effect of pressure. In starting, we are having a minimal pressure. This is the piston over here. Now lower pressure means lower concentration over here. Now we are having the pressure increasing. Now when the pressure is increasing, it means the particles are coming together and there will be the higher concentration in that area. Next is effect of concentration changes. So if I talk about the reactants, increasing the reactant, concentration shifts equilibrium towards the product. and if you are going to increase the product concentration, it is going to shift equilibrium towards the reactant. Then effect of addition or removal of a catalyst. Now the work of the catalyst is what? To increase the rate of the reaction over here. So when you are going to add a catalyst, it does not affect the position of the equilibrium. It is only what doing the speeding up the attainment of the equilibrium. Next is the over here I'm not explaining the complete Haber's process because the question is never being asked about the Haber's process, about its explanation. The question comes over here that write down or the favorable conditions for the Haber's process and the contact process. So in the case of the Haber's process, the temperature required is 400 to 450 degrees centigrade. Pressure is 150 to 300 atmosphere. Catalyst iron with potassium oxide as the promoter. In the case of contact process, around 400 to 450 degrees centigrade temperature. High temperature favors the formation of SO3 but can also lead to the thermal decomposition. Pressure, atmospheric pressure, and catalyst vanadium pentoxide we use over here. Next comes the redox reaction. Now when we are talking about the redox reaction, over here if you look, you can just bifurcate this word into red plus ox. Now this redox to red plus ox, it came from the reduction and oxidation. Okay. Now a redox reaction over here, it involves the simultaneous oxidation process, that is the loss of the electrons, and reduction means the gain of the electrons. So basically it is a process between the reactants and altering their oxidation state. Like over here if you look, in this particular case, copper oxide, from here there is the removal of the oxygen. So we can say the reduction has taken place, and for the H2 there is the addition of the oxygen. So we can say the oxidation has taken place. Now in terms of the your oxidation state, if I talk about, you know the oxidation state of the oxygen is -2. So copper is going to be the +2. Now when it is going to over here, it is converting into a copper. So what is happening? Oxidation number is changing from +2 to 0. So there is what? Decrease in oxidation number. So when decrease in oxidation number means what has happened? Reduction taken place. Okay. And over here it is 0. Where it is going that side? So it is going to be what? Plus 1. And for the 2 it is going to be the +2. So what is happening? The oxidation number is increasing oxidation number. So that's why we are going to say it as a oxidation. So redox reaction, if a substance gains oxygen during a reaction, it is oxidized, and if substance loses oxygen during a reaction, it is reduced. So we have seen this particular example already. Like over here, oxidation is defined as the process in which a substance gains oxygen or increases its oxidation number. Like in the case of Fe plus O2, it is giving us the Fe2O3. Then over here, oxidizing and reducing agent. If I talk about the oxidizing and reducing agent, oxidizing reagent is a substance that facilitates the oxidation in another substance by promoting the gain of oxygen or an increase in oxidation state. Whereas reducing agent is a substance that facilitates the reduction in another substance by donating electrons or decreasing in oxidation state. So basically what you can say, the one which is being reduced, it is going to called as a oxidizing agent, and the one which is going to be oxidized is going to called as a reducing agent. Now comes the oxidation number. Basically oxidation number is a measure of electrons lost or gained by an element in a compound. So compound names often include Roman numerals, especially after transition metal names such as copper 2 sulfate, iron 3 oxide, copper 2 cobalt 2 chloride. So transition metals exhibit the variable valency leading to different oxidation states. For example, iron can have the iron 3 oxide, that is the 3 plus oxidation number, copper in copper 2 sulfate Cu2 plus, and so on. So these metals can form ions with different charges in various compounds. For instance, iron can also exist as the Fe2 plus and copper can exist as the Cu plus ions. So these number basically denotes these charges and termed as the oxidation number or the oxidation states of the elements within a compound. So this was all about the important topics from where we get a question from the chemical kinetics. Now over here, let's see the type of the questions over here. And look, you will just observe that in a single paper only we are getting at least 4 questions. Why the 4 questions? Because in the case of the chemical kinetics, we study about the chemical kinetics, we also study about the equilibrium, we also study about the chemical reaction, that is the reversible or the irreversible or the physical change or the chemical change, and we talk about the redox also. So that's why in every single paper of MCQ type you get the 4 questions from this particular unit. So let's see the type of the questions. Like the first question is from the variant 12 February March 2024. Which reaction is reversible reaction? Now reversible reaction means what? That product can convert into a the reactant is converting into a product, at the same time the product is converting into a reactant. So let's see over here, reaction of aqueous sodium hydroxide with dilute HCl. Now look, sodium hydroxide is what? It is NaOH, and dilute HCl is what? It is HCl. So it is going to give us the NaCl plus H2O. Now basically this is a neutralization reaction, and this neutralization reaction is not reversible. Then formation of anhydrous copper sulfate from hydrated copper sulfate. Now look, basically if I talk about the copper sulfate dot 5H2O, if I am going to heat it, it is going to convert into a CuSO4. But at the same time, if I am going to put a water in that, it is again going to convert into a hydrated form. Now the question is asking us which one is reversible. So option B is going to be my answer. Like over here, oxidation of methane. Oxidation of methane means that you have taken a methane, burn it in the presence of the oxygen. So you are going to get the CO2 plus H2O. Okay. Combustion of sulfur to form the sulfur dioxide. So over here what is happening, that you are taking a sulfur plus O2 and you are burning it and you are getting a sulfur dioxide in this particular case. So here we prove that option B is going to be our correct answer. Okay, coming to the next question. So next question says silver oxide reacts with magnesium to make silver and magnesium oxide. Okay, now look, it's also from the variant 12 February March 2024. So which substance is oxidized in this reaction? Now look over here, basically what is happening, that silver oxide, when you are saying, it is having the oxygen over here plus magnesium, giving us 2Ag plus MgO. Now from silver we are removing a oxygen. It means it is undergoing a reduction, and magnesium is converting into a magnesium oxide, so oxidation. So the correct answer is going to be option A over here. Coming to the next question, an experiment is set up as shown. The mass of the conical flask and its content is measured at 30-second intervals. Which statement about the reaction and changes to the reaction conditions is correct? Now look, again it is from the variant 12 February March 2024. The third question you are looking from the same paper. Now we are given with the 50 centimeter cube dilute HCl, 1 gram calcium carbonate. This is particular aqueous form, this is a solid form. Now it is saying which statement about the reaction and changes to the reaction conditions is correct. Adding 10 centimeter cube of water to 50 centimeter cube of acid increases the rate of reaction. No, because when you are going to add a water to it, you are diluting it. You are not increasing the concentration of acid over there. Then increasing the size of the piece of calcium carbonate increases the rate of reaction. Again, no. Why? Because we have seen that if you are going to use a powdered substance, then the rate of reaction is going to be more. Then increasing the temperature increases the rate of reaction. Yes. When we are going to increase the temperature, the rate of reaction is going to increase. Why? Because there will be the more kinetic energy for the particles. So, they are going to collide frequently. Then the mass of the conical flask and its content increases as carbon dioxide is formed. So, this particular statement nothing to do with the rate of the reaction. Coming to the next question. Now look, this is the fourth number question from the same variant. Okay. So, you can just see that how frequent we get a question over here. Which list contains only chemical changes? Now, when we are talking about a chemical changes means there will be the bond breaking, new bond, formation. Besides that, there will be the new product also. Okay. So, melting, evaporating, dissolving, they are not the chemical changes, but they are the physical changes. If I talk about the rusting, freezing, cracking, so freezing is not a chemical change. Neutralization, polymerization, combustion. Yes, in neutralization we get a salt and over here the water molecule. Polymerization also it is a addition product, and in combustion also the oxygen is added. So, option C is going to be our answer over here. Coming to the next question. In experiment 1, small lumps of limestone are added to the dilute ethanoic acid at 40 degrees centigrade. The volume of carbon dioxide released is measured at regular time intervals. A graph of the results is shown which changes give the results shown in experiment 2. Which list contains only chemical change? Okay, so it is saying that in experiment 1 we used a lumps of the limestone to the dilute ethanoic acid and temperature is 40 degrees C. Then which change give the result shown in experiment 2? Which list contains only chemical changes? So, let us see over here the list. We are having the large sums, powder and smaller lumps. Now look, if you just recall the graph over there, the experiment 2 is having the lower gradient. So when it is having a lower gradient over here, it means I am having the larger lumps. Okay, and it is saying that which list contains only chemical changes. So basically the temperature is going to be the same and larger lumps. Then in Haber's process, nitrogen and hydrogen are reacted to make ammonia. The forward reaction is exothermic. Now it means that delta H is negative. So which condition produces a maximum yield of ammonia? So if we want a maximum yield for the ammonia, we require to have a high pressure and the low temperature. So option B is going to be the answer. Coming to the next question. The next question is the Ostwald process. Now, what is the Ostwald process? It is used to make the nitric acid, that is our HNO3. The conditions used in this process are a catalyst containing a transition element, a pressure of 10 atmosphere, a temperature of 800 degrees centigrade. Which of these conditions are also used in contact process? Now, contact process is what? It is the manufacturing of H2SO4. Okay, if I talk about the conditions, we use a vanadium pentaoxide. Then we use a temperature of 400 to 500 degrees centigrade. Then besides that, we use a pressure also over here. So if I look over here, the condition which is resembling the Ostwald's process, that is the first option only. That is the transition element, that is V2O5. Okay. Then next question, a method used to investigate the rate of reaction of calcium carbonate with dilute HCl under different conditions is shown. Place 50 centimeter cube of dilute HCl in a conical flask. Add a known volume of water to the conical flask. Heat the conical flask to the required temperature. Add 1 gram of the calcium carbonate to the conical flask. Measure the time taken for the reaction to finish. Which volume of water and which temperature give the shortest time taken for the reaction to finish? Okay. So in starting we took the 50 centimeter cube of dilute HCl and the known volume of the water. We heated the conical flask and added the 1 gram of the calcium carbonate to the conical flask and measure the time. Which volume of water? Now look, it means the lesser volume we require to take, so I can expect from A and B. And temperature give the shortest time. Now more temperature I require to have. Why? Because there will be the more kinetic energy. So like this, option B is going to be my correct answer. Coming to the next question. It says the rate of reaction between magnesium and hydrochloric acid is investigated. The total volume of hydrogen given off is measured at different times. A graph of the result is shown which conclusions are correct. The rate is fastest between 0 to 30 seconds. So if I look, 0 is here and 30 second is over here. Yes, it is fastest. So this is correct. The maximum volume of hydrogen given off is 22 centimeter cube. So if I look over here, then 20, 21, 22. Yes, this is also over here. Then at 40 seconds, 20 centimeter cube of hydrogen is given off. So 40 seconds I am having, and at 40 seconds if I look, this is lower than the 20 centimeter cube. So basically over here, if I look, then my statement 1 and 2 is going to be the answer, not the third one. Next question, which equation represents the oxidation reaction? Now oxidation reaction means what? That there should be the simultaneously reduction and oxidation. Okay. So first case if I look, there is no oxidation reduction. It is a decomposition reaction. FeO plus O2. Now look over here, there is the addition of oxygen. So answer B is going to be my correct answer. Next, which of the process produces a physical change? Now physical change means that no bond formation, no bond breaking, no new compound. Decomposition of calcium carbonate give us the calcium oxide plus CO2. Okay. Addition of magnesium to hydrochloric acid means what? That the magnesium plus 2 HCl is going to give you the magnesium chloride plus H2 gas. Combustion of sodium means Na plus O2, which is going to give you a Na2O. Okay. So now sodium chloride plus water to water. It means you're just dissolving NaCl in the water. So option B is going to be our answer. Next is, which of the reactions show the underlying substance being reduced? Now, if I talk about being reduced, over here, if you look what is happening, from the copper oxide, oxygen is removing. So option 1 is going to be my answer. 2 and 3 cannot be, because in 2 there is the addition of the oxygen, and in the case of the 3 again there is what? The addition of the electronegative element. Next. Hydrogen is made by reacting carbon with steam. The equation for the reaction is shown. The forward reaction is endothermic. Now look, it is reverse. So which row describes the changes in pressure and temperature that will shift the position of the equilibrium to the right? So now it is reverse. So we should have the decrease in pressure and increase in temperature. So option B is going to be our answer. Next is, which statements explain why increasing the temperature changes the rate of chemical reaction? Now, if you are going to increase the temperature, what is going to happen? There will be the more kinetic energy. When more kinetic energy, the collision frequency is going to be more. So, option 2 and 3 are correct over here. So, option C is going to be the answer. Next is, A student adds excess magnesium ribbon to 10 centimeter cube of 0.5 mole per decimeter cube sulfuric acid. The hydrogen gas produced is collected and its volume is measured by every 10 seconds. So the experiment is repeated with 5 centimeter cube of 0.5 mole per decimeter cube sulfuric acid added to 5 centimeter cube of water using the same mass of magnesium ribbon. Which line on the graph shows the results of the second experiment? Okay, so we are given with the D, C, B and A. So original line also we are given with. So over here, if I look, the question is saying line graphs results of the second experiment. In the second experiment, what we did, the concentration is sulfuric acid is same. We have taken a 5 centimeter cube over here and it is added to 5 centimeter cube. Okay, so of course it is going to be lesser. So option D is going to be the correct answer. The equation represents a reversible reaction between the ethene and steam. So delta H is negative. Now negative means that this particular reaction is exothermic in the nature. Now the question is saying describe the conditions that produce the greatest yield of the ethanol. So it is going to be the high pressure, low temperature. So option C. Next is which equation represents a redox reaction. So again redox means oxidation and reduction should take simultaneously. So AgNO3 and AgCl, we are getting the AgCl precipitate. So no for this. Over here also PCl5 is converting into a H3PO4 and 5HCl. So again no. Fe is converting into Fe3O4. So addition of oxygen. So option C is going to be my correct answer. Next is the equation for the reaction between aluminum and copper oxide is shown. Which statement about this equation are correct? The oxidation number of aluminum reactant is +2. Now look over here. Over here if you look, then aluminum is oxidation number is 0 over here. So this is going to be the wrong statement. Then oxidation number of aluminum in the product is +8. So this is not possible. Then the oxidation number of copper in the reactant is +2. Yes, it is correct. Why? Because oxygen is -2. Then the oxidation number of copper product is 0. Yes, this is also the correct. So option 3 and 4 are the correct statements over here. Next, which row identifies a pressure catalyst used for the conversion of sulfur dioxide to the sulfur trioxide? So basically, if I talk about your catalyst, it is the vanadium pentoxide, and if I talk about the pressure in the atmosphere, it is going to be the 2. So option B is going to be the answer. It is very crucial to check out the unit over here. If it could be kilopascal, then it is going to be the 200. So this was all about for this chapter discussion. I hope you enjoyed the session and learned that what all topics you require to focus while preparation of your exams for these upcoming exams, I should say, and the type of questions also you have seen. For such more video lectures, just follow us till then. Goodbye.